In this tutorial we're looking at section 14.2 on population parameters and sample statistics. Now before I get started, I really want to make sure that you understand that chapter 14 is our main new section in the new study design. So what that means is when you come to a revision and you're doing practice exams, things like that, any of the VCAR exam papers won't have this stuff on there. So you really need to make sure that you're doing all the questions that your teacher sets, and probably even some extra ones, and make sure you're revising really well on this content leading into exams, because as I said, a lot of the older practice exams that you'll be doing just don't have this information on there. Okay, so there's a fair bit of terminology that we need to get our head around for this chapter. So to start off with is population is a group that you want to know something about. Okay, a sample is a group within the population that you collect the information from. Okay, population size is capital N. Okay, is the number of members in the population. Sample size is lower n, is the number of members in the sample. Okay, a parameter is a characteristic of a population, and a statistic is a characteristic of a sample. A statistic is known exactly. A parameter is estimated from a sample statistic. Now, in the book they talk about the fact that you can know what the parameter is, or you can have a statistic for a population when they talk about the census. So the census occurs every 7 years, and the idea is that everyone in Australia is surveyed on a whole heap of information, and that goes into a central source that the government uses to make a lot of decisions. However, it's not actually a perfect method of sampling, okay, because if you're homeless and you don't have a fixed address, then you won't actually end up on the census. But it's as close as what we can get to the perfect sampling method. And so talking about sampling method, okay, random samples. Okay, so a good sample should be representative of the population. Okay, so a random sample means that every member of the population has the same chance of being selected. Okay, so you want things to be random. Okay, otherwise you're going to end up with biased data. Okay, a systematic sample, that just means like every kth member of the population is selected. So it could be every 10th person who enters a shop is selected to do a survey or something like that. Stratified random samples. So this ensures that every subgroup in a population is selected in the same proportion to the population. So members of each subgroup are then randomly selected. So an example of that is you might be looking, your population might be all students in years 9 to 12. Okay, by doing a stratified random sample, you're going to make sure that students from years 9, 10, 11 and 12 are selected. Okay, and in the same proportion as they occur in the whole population of year 9 to 12. Okay, and then members within each of those year levels are chosen randomly. Okay, and self-selected samples. Okay, so individuals choose to participate, and these are the least representative of the population. Okay, so the self-selected samples are really the worst type of sampling there are. Okay, and often it's the most common way that things are done, because you get people like telemarketers calling up while individuals choose whether they want to actually answer the phone or actually answer their questions when they call, and a lot of things like that. News polls in newspapers are also self-selected, because you've got to text in your response, that sort of thing. Well, people are choosing whether they want to do that or not. Okay, and depending on what they're talking about, people will be more likely to worry about actually being involved or not. So we'll have a look at some worked examples. Okay, so we've got worked example 1. Cameron has uploaded a popular YouTube video. He thinks that the 133 people in his year group at school have seen it. He wants to know what they think. He decides to question 10 people. Identify the population and the sample. Okay, so the population is what he wants to know about overall. Okay, so the population would be, the capital N would be our 133 people. That's all the people in his year level. Okay, the sample, sample size, that's our lowercase n, that's the 10 people he's going to question. Okay, and that's all there is for worked example 1. Okay, worked example 2. Okay, a total of 137 people volunteer to take part in a medical trial. Of these, 57 are identified as suitable candidates and are given the medication. Identify the population, okay, and the sample size. Okay, 157 people are given the medication, so this is going to be our sample size. So our little n is going to be 57. Okay, you would be tempted to say our big N is 137, but it's not. Okay, because the population is unknown, as we don't know how many people may be given the drug in the future. Okay, so we can't actually know what the population is, so that is actually not right. Okay, and is not equal to 137. We actually don't know what it would be. Okay, work example 3. Okay, we're going to identify the following as either sample statistics or population parameters. Okay, so the first one is 43% of voters polled say they are in favour of banning fast food. Okay, well that's going to be a sample statistic because it's only those people that were polled. Okay, according to the Bureau of Statistics census data, the average family has 1.7 children. Okay, we take the census to actually be reliable and cover everyone, so we're going to call that the population parameter. Okay, part C is between 18% and 23% of Australians skip breakfast regularly. Okay, that would be a population parameter. Okay, and 9 out of 10 kids prefer cereal for breakfast. Well, this would be a sample statistic for that one. Okay, so there's actually nothing that we need to worry about writing down for work example 3. Okay, work example 4. Okay, a survey is to be conducted in a middle school that has the distribution detailed in the table below. So our table is year level, right, and number of students. Okay, and our year levels are 7, 8, and 9. Okay, number of students are 174, 123, and 147. Okay, it is believed that students in different year levels may respond differently, so the sample chosen should reflect the subgroups in the population. That is, it should be a stratified random sample. If a sample of 100 students is required, determine how many from each year group should be selected. Okay, so our total population, okay, all up, when we add them together, okay, is our total population is going to be 444. Sorry, and that's really our N. Our capital N is 444. Okay, so our number of year 7s, okay, so we want the same proportion. So our proportion of year 7s is going to be 174 over 444. Okay, if we times that by 100, okay, then we get 39.1. Okay, so we should have 39 students surveyed. Okay, for our year 8s, okay, it's 123 over 444 times our 100. Okay, it means we get 27.7. So we should be 28 year 8s. Okay, and for our year 9s, okay, that's 147 over 444 times our 100. Okay, it means it's 33.1, which is 33 students. Okay, when we add that together, we do in fact get our 100. If we go 39 plus 28 plus 33, we get to our 100. Okay, so we've got our 100 students. Hey, we could have had rounding errors there that meant that we didn't quite have enough, so it's good to double check. Okay, and that's all there is to it. Okay, you can use technology to select the sample. Okay, if you know the population size, it should also be possible to produce a list of population members. You'd assign each population member a number from 1 to n, okay, and use a random number generator on your calculator to generate a random number between 1 and n. The population member who was allocated that number becomes the first member of the sample. Okay, and you can continue generating random numbers until the required number of members has been picked from the sample. If the same random number is generated more than once, ignore it and continue selecting members until the required number has been chosen. Okay, so we can actually get our calculator to randomly generate numbers, okay, and have those numbers assigned to people in the population. Okay, of course, when we do a random number generator on our calculator, it is actually following an algorithm. So it's not 100% random, but for basically what the purposes of what we need, we can consider that to be random. Okay, so hopefully that's everything that you need and you should be able to get through these questions okay.